So first we'll discuss how to design Butterworth filter. Okay. So to design Butterworth filter, we have to follow these are the steps. The first one is for given specification. What are the specifications are given? You see this figure, all of you. Okay. So alpha P will be given. Okay, it will be actually negative value, but when we are finding value of n, we have to consider that negative. So if it is given negative also, have to take positive only for alpha p and alpha s. Okay, so these two values, these are the passband attenuation in dB. Alpha s is the passband attenuation, stop band attenuation in dB. Okay, and ohm p is the passband frequency, ohm s is the stop band frequency. These are the four specifications are given. Okay, if it is given in dB, you have to take alpha p, alpha s. Sometimes this will not be given in dB. So what are the values will be given here? The values are given as 1 by root of 1 plus epsilon square. This is the value at the stop band. This is the pass band attenuation value. Okay, 1 by root of 1 plus lambda square. This is the stop band attenuation value. Okay, this is the value at the stop band, whereas this is the value at the pass band. Okay, so these are the four specifications are given. Alpha p, alpha s, ohm p, ohm s are 1 by root of 1 plus epsilon square, 1 by root of 1 plus lambda square, alpha p, alpha s. Okay, sorry, ohm p, ohm s. These are the four specifications are given every time when we want to design the filter. Okay. So once these specifications are given, what is our first step is to find out the value of n. How do you find out value of n? If alpha p, alpha s are given, okay, so you have to take only the positive values. If it is given negative also, we have to consider only positive. I told you, no. So use this formula. So n value should be equal to log base 10 here, ma. Log base 10 root of 10 power 0.1 alpha s minus 1 by 10 power 0.1 alpha p minus 1 by log base 10 ohm s by ohm p. Okay, this is the formula if alpha s, alpha p are given. Okay. For example, if 1 by root of 1 plus epsilon square, 1 by root of 1 plus lambda square is given, what is our first step is to find out epsilon and lambda. So after finding epsilon and lambda, you have to use this formula. This is also n is equal to log base 10 lambda by epsilon log divided by log base 10 ohm s by ohm p. Okay, so after finding n value should be always you are getting a real number. Okay, you'll be getting in decimals. Okay, so that should be rounded to next higher integer value. For example, if you are getting it as 2.1, okay, that should be rounded to 3. Okay, if you are getting 2.9 also, it should be rounded to 3. Whatever value you get after decimal point, immediately it should be rounded to next higher integer value. So after finding n value, what is our first step is in Chebyshev. See here we are doing Butterworth low pass filter. No, whenever you are designing Butterworth low pass filter, first we have to design normalized transfer function of that filter. Okay, what is normalized means? Normalized means what? Cutoff frequency is equal to 1 radian per second. Okay, so to find out the transfer function for cutoff frequency is equal to 1 radian per second, what is our first step is to find out the poles. How do you find out the poles? Sk is equal to e power j phi k. This is the formula we have to use to find out the poles. What is phi k here? Phi k is equal to pi by 2 plus 2k minus 1 pi by 2n, where k value is varying from 1 to 3, so on n. Okay. So after finding phi k, what is that? Our first step, next step is to write the transfer function. H of s is equal to 1 by the product of s minus sk. Okay, how many sk values we are finding? K value is varying from 1 to n, no? So you have to take the product s minus sk for k is equal to 1 by 1 to n. Okay, so after finding the transfer function of normalized low pass filter, it is okay. So what is the cutoff frequency is 1 radian per second. So what is next step is to find out the cutoff frequency. So the cutoff frequency is given as ohm c is equal to ohm p by 10 power 0.1 alpha p minus 1 whole power 1 by 2n. This is the formula we use to find out the cutoff frequency. After finding cutoff frequency, now we have to design a low pass filter with the given cutoff frequency ohm C. How do you find out the low pass filter with the given cutoff frequency ohm C? So what we have to do in H of S, this is the form we got, no, H of S, replace S with S by ohm C. Okay, so that you get a filter with a given cutoff frequency. Okay, in H of S we have to replace S with S by ohm C. So you get this given cutoff low pass filter with a given cutoff frequency. Okay, these are the steps. Okay, what is our first step, ma? Find out. So you have. Okay, see the students here. Um Alpha p is negative. 1 second, students.